Today we'll be graphing radical functions, which are functions underneath a square root sign. The functions we graph will usually have this shape. It has a starting point and then it will go on forever. The reason it looks this way is that when the expression under the radical is negative, this function doesn't exist. At least it's not a real number, and we only graph real numbers. I'm on page 95 in the packet. First, we review drawing a graph from a table. Remember that x is the independent variable. It can be whatever as long as the function has a real result. The y values of the graph will be the values of our function. If we have the function g of x equals x, then the value of g of x when x equals 4 is -4. When x equals -3, it's -3, and so on. This is a linear function. It will be a line. And remember, with a line, we don't need all these points. We just have to find two and connect them. But when we draw curves, it helps to get several points. The more points you have, the better you can draw it. Essentially, using multiple points increases the resolution of your graph. You can get a smoother curve. Before we move on to the radical functions, let me answer these questions. What is the domain of the function? The domain is everything x can be, and g of x is real for every value of x, so the domain in interval notation is -infinity to infinity. The range is everything y can be. It's everything g of x can be. And you can see that that goes from -infinity to infinity as well. And remember, we always use rounded brackets with infinity because nothing ever gets there. The function is shaped like a line. What is the exponent on the variable? It's 1. X is the variable, and we have x to the first power. Does it continue forever to the right? Yes. Forever to the left? Yes. And it's called a linear function. Now we want to graph a radical function. F of x equals the square root of x. First, let's fill in this table of values. When x equals -4, f of x is the square root of -4, and that's not a real number. So I'll write DNE for does not exist. This number does not exist in the real number system, so we can't graph it. When x equals -3, f of x does not exist either. F of x is not a real number until x equals 0. And then the square root of 0 is 0. The square root of 1 is 1. To graph this, I'm going to need a number for the square root of 2. That would be 1.414. The square root of 3, 1.732. And the square root of 4 is 2. We plot these points on a graph. It's going to look something like this. We have a curve. What is the domain? The domain is everything x can be. X can't be less than 0, but it can equal 0. We'll use a square bracket. There is no limit on x once it's positive, so the domain is 0, infinity. What is the range? The range is everything y can be. That's everything the square root of x can be. The square root of x is always positive, but it can keep increasing forever. So the range is 0 to infinity as well. It is a curve. What is the exponent on the variable? It's 1/2. Remember that the square root of x equals x to the 1/2 power. Does it continue forever to the right? Yes. Does it continue forever to the left? No. It stops at x equals 0. This is called a radical function. In the previous problem, the domain and range matched, but that won't always be the case. Take the function f of x equals the square root of x minus 1. In this case, the domain is 1 to infinity, because when x is lower than 1, we'll be taking the square root of a negative number. When x is 1, f of x equals 0. When x is 2, f of x is the square root of 2 minus 1, which is 1. When x is 3, we'll have the square root of 2. When x is 4, it'll be the square root of 3, so it'll look kind of like that. And we can see from the graph that the range of this is 0 to infinity. If the 1 is outside the radical, so that g of x equals the square root of x minus 1, then x can't be lower than 0. When x is 0, g of x equals negative 1. When x is 1, g of x equals 0. When x is 2, it's 1.4 minus 1, and so it's going to look like this. The domain is 0 to infinity, and the range is negative 1 to infinity.